All right, now let's attack this guy. Now this guy has some gnarly factoring tricks that maybe you've never seen before in your entire lifetime. Okay, if I were to plug in infinity to the top, that would just go towards infinity. So this would be infinity, and then if I unplug infinity in the bottom, this would be infinity and be plus 1, which is just really infinity, because how can you really add 1 to infinity, because it's just still infinity. And then the square root of infinity would still be infinity. Or you can think about the square root function. It would just the square root function looks like this, and as you go towards infinity, we're still approaching infinity because this arrow is pointing not only to the right but also up, so it's going towards infinity. All right, all that to say, we have infinity over infinity, which is indeterminate form. So what do we do with this? How can we manipulate what's inside to find out what's happening here? All right, now this is weird. I know it, and you're like, how do you know that? It takes practice. We're gonna factor right here. Okay, ignore the square root for a second. Our greatest exponent would be x to the third, and so I'm going to divide by x to the third. Actually, I'm going to factor here. So I'm going to just stay down here for a little bit. I'm going to manipulate this, and this is what it's going to look like. All right, the top's going to stay the same, just x squared, and then we're still going to have this square root right here. But inside, I'm going to take out an x to the third. I'm going to take an x to the third out of x to the third plus 1. So what is x to the third divided by x to the third? If I divide x to the third by x to the third, that just equals 1. So I have a 1 right here plus, and what would I get if I divide 1 by x to the third? Well, you would just get 1 over x to the third. Don't worry about it, just leave it. Okay, now why would you do that? Well, you would do that because now you have two numbers multiplying to each other inside of a square root, and now you can actually manipulate that a little bit more. You guys remember back in the day when you took like a square root of 2 and you multiply it times the square root of 3? That equals square root of 6. What? Okay, so if you didn't know this, you can be like, oh, I could split up this 6. I can say square root of 2 times 3. And then you can rewrite that as square root of 2 times the square root of 3. Right? Yeah, so we have, this is, pretend this is the 2, pretend this is the 3. Okay, when we rewrite this, it would look like this. Square root of 3, or square root of x to the third, times the square root of 1 plus 1 over x to the third. Wow! Okay, all right, so we just went from here to here, and I think that's the most complicated part, because people are like, what, you could do that? I didn't know that. Oh my gosh, all my life. No, I'm joking. But now we can simplify more, and you might not see it right away because you haven't done it enough. You can rewrite this guy to say x to the 3 over 2, okay? Because that's the root. The root is 2. This is a second root. It's a square root, so we put a 2 right here. And then the power is 3. And that's cool. This is cool. Why is this cool? Because now this is multiplying to this, which means I can simplify these guys. What do you do with those exponents? Yes, subtract. Okay, so let's look at this 2 like it's... let's see, we gotta have a 2 on the bottom, like it's 4 over 2. So what is 4 over 2 minus 3 over 2? That is gonna be x to the 1/2, and on the bottom we still have this guy. Square root of 1 plus 1 over x to the third. All right, let's see what happens. We're gonna take the limit as x approaches infinity. The top, if I plug in big and bigger numbers right here, it's just gonna go towards infinity, and then it doesn't equal, so I'm just gonna put an arrow right there. And on the bottom, oh dang, this guy has an x on the denominator, which means it's going towards 0. And so we're just left with the square root of 1, which is just 1. What is infinity divided by 1? It is infinity. Man, this has got to be the most unsatisfying answer ever. So this function right here, as we approach the right side of the graph, we're going towards infinity.